obviously Ed lives in the future, so.
Yeah. Yoshka just now pointed out to me my year typo on my slide. Says I am so far in the future that I thought I was speaking at Emberfest 2025.
I love the optimism, thank you. All right, so this is both very sad and very, very happy moment to introduce Ed, but he's also the last talk. So I need all the energy left in the room to welcome Ed on stage. Give him a big round of applause for the closing keynote of this very conference. Hi, Ed.
Thank you. All right, so I got the closing keynote spot, which is often really like a high-level, big picture, little fluffy, inspiring talk, and this is not going to be that. I have too much technical detail to dump on you. There's going to be a fire hose of technical detail. Brace yourselves. No, but don't panic. All the code I'm going to show you is shared already on GitHub. You could follow along at your own speed. I want this to be a talk that is a resource you can come back to when you think of something that you're like, oh, I wanted to remember how that works. And the point of this talk is I want you to come away feeling that Ember's whole development experience and build environment is not mysterious, and it's something that you can learn, and when you need to, you can learn it better and grow and have that growth opportunity, and then be somebody who can help us innovate it and help maintain it and help contribute to it. So I'm going to start, though, before I go into the nitty-gritty, with porgs, which, if you aren't familiar, are these adorable aliens in one of the Star Wars movies. But I put a porg on here, well, because Chewbacca's out of the room now, so we don't have to worry about the porgs being eaten. But you might not know that these scenes of Star Wars were filmed in Ireland, so that's my Ireland hook. They were filmed on a little island off the west coast of Ireland, and they were not originally in the plan for the movie. They were an idea on the fly because when they went out to scout the scenes, they realized that the whole island was covered in puffins, and they were in all the shots, and it was going to be easier to replace them with a little alien than edit them out. So that's how porgs got created. And this summer, part of what I got to do is I did actually get to see real puffins. This is the best photo I was able to get of them. And this was about 10 kilometers off the coast of Maine in the northeast corner of the United States. Puffins like this live out at sea all their lives almost, and they only come to land to raise their young. I got to see them because my family and I went to this camp in Maine for a week. This is like what I did this summer. It was a really cool experience. Not only did we get to see the puffins, but we got to meet one of the scientists who started many years ago, 50 years ago now, the program that brought those puffins back to that part of the world because they had been driven extinct. And as a young biologist, he kind of just had this crazy idea that he could bring them back, and got a little money to try it and started hand-feeding baby pufflings on the island summer after summer, hoping that eventually some would come back as adults and start a colony again. And they stuck at it for about 8 years, every summer, bringing little baby puffins from other places and hand-feeding them fish with extra vitamins and trying to tweak their procedures and adapt and change. And after about 8 years, they finally succeeded and got puffins coming back. So it's just a really inspiring story that I think has an inspiring lesson for all of us about like sticking to it and making the world a little better. So that was my what I did this summer. So I titled this talk Ember from Scratch, not because I think everybody should have to make their own Ember setup from scratch. Blueprints are great. Our shared solutions are great. That's a really important value to our community. You should be able to get started without having to dive into the details, and none of that's going to change. But I wanted to use this talk to show you how you could understand how to build up an Ember development experience from scratch, because I think it's a good teaching opportunity, and I want to demystify it for people. I want to show you how far we have come into simplifying that process. So I am going to go into a bunch of detail, and we're going to build up from nothing a fully working Ember development experience focused on all of the newest stuff we've got. So our strategy is going to be just to try something out, see the error that it gives us and why it doesn't work yet, and learn from that. And we're going to try to make it work. Then we'll worry about making it pretty, and then we'll repeat. And you can follow along with the code. That's the repo up there. That the commit you'll see if you just see main is the final stage. There's commits along if you want to follow along with the talk. So we're going to start with an extremely empty project, nothing but an empty HTML and a package.json with no dependencies. So we're playing on hard mode. So how do we make an Ember app from nothing? Right? It's not something most of us probably sit down and do. But the first thing we're going to need to do is import application class from Ember application. So we put that in. And of course, this isn't something that's going to run yet. There's a couple of reasons why, but browsers aren't going to know what to do with this. And we're at least going to need a web server. So we're going to install Vite to be our development web server. And now when we start Vite up and we look at our app, it's going to tell us, I don't know what Ember application is. And that makes sense because Ember application isn't a real package. All we have, I did say on the previous slide, I guess, is that I have Ember source, right? So I do have Ember source, but the package is named Ember source, right? Not named Ember application. So we're gonna worry about that in a moment. But for now, we're just gonna make it work before we make it pretty. So we're gonna tell Vite exactly where that file really is in the package. And so now we don't have a build error anymore. Now we have a runtime error, and that really is progress. That kind of stuff should get you excited when you're trying to solve this kind of problem, because a new error that moves you farther along is good. And it's a new opportunity to learn what you need next. So in this case, the error we see says, oops, this method's really implemented at compile time. If you're seeing this, something went wrong. And if we look at where it happened, it's in the embroider macros package. So embroider macros is what we created to be one standardized place to encapsulate allowing Ember code, Ember add-ons, and libraries to customize their build in one standard way so that there's not a million different ways they can customize their build. But we do need support for that, and we don't have it. So what we're going to need is we're going to need Babel in order to plug that support in. So we're going to go and add some dependencies, 5 dependencies. Vite uses rollup plugins. So the rollup plugin Babel is what we're trying to get here to turn Babel on in Vite. And it needs Babel core. That's how you figure out what Babel version it's going to use. And we're also installing 3 embroider packages here because we're about to use plugins out of them. These are all published packages on our unstable channel. That's what main publishes to. But like they're real packages you can go use. They're only unstable in the sense that we don't have the polish and the docs and all yet that we have on our stable releases. So we added our deps. Now we're going to create our Vite config for the first time. This is a Vite config file. It's only really doing 2 things. It's turning on Babel by installing the Babel plugin. And it's doing the second thing, which is the embroider Vite package is giving us some settings called optimized deps. And this is there. All you really need to know about this at this stage is that Vite has really very different ways that it builds your code and your libraries that you depend on and your deps that it optimizes. And so all this is really doing is making sure that all the things that we're setting up, including the Babel and all the other things we're going to set up, they're going to apply to our deps too. That's what that's doing for you. All right, so now, and we also, since we have Babel, we get to make a Babel config file. And our Babel config file is just installing one thing. It is embroider compat is giving us this compat support feature that we're going to drop right in. And this does several things for us. This is all the baseline stuff that you're just going to need to keep traditional Ember code working, and that you don't really, and this is specifically the stuff that you shouldn't have to worry about. It's the things that are just there because, for example, like the macros, they're just standard, and you shouldn't have to worry about any setup more complicated than that. So now when we go and look at our app, it's running. There's no errors in our console or our browser. We do have some noise in our console, and I don't want noise in our console. So these are just some warnings coming out of Babel. And so we're going to go ahead and add a couple more settings just to make those. We're following the instructions in the warnings to make things nice. So there were some defaults being used. We're filling in the defaults and making sure that we have a nice, lovely, quiet console now. So this is what you see when you run Vite dev. It's just plain and empty, which is very nice. Because now when we do see problems, we're going to see them more clearly. We're not buried in a spew of error messages. So it's running. Of course, it's not doing anything yet, but we're seeing no errors. So let's go and fix the problem we mentioned earlier, where our import was a funny one. we really want to make it look nice again and follow all our conventions. So we're going to go ahead and make that change. And to make it work, we have to plug in Embroider's module resolver to Vite. So this is doing one thing. We're importing the resolver plugin from Embroider Vite, and we're adding it to the list of Vite plugins. And this plugs in a whole lot of the smarts that is the secret sauce that makes Embroider able to keep all of our code working under different build conditions. Most of what it does is implemented in Embroider Core. That's why we had to install Core. It's a peer dep of Embroider Vite. And Embroider Vite here is really just the glue that knows how to make it be a thing that plugs into Vite. But that same logic is the same logic that we plug into Webpack. And actually, behind the scenes is the same logic that's plugged into the optimized deps here too, because this is being run through a whole third build system, which is ESBuild. But all of that is nicely encapsulated for you in Embroider Core. So the reason we're adding this resolver is this is where we encapsulate all the rules about how imports get mapped to where they really go. And so something like @ember/application is going to go to the right place because the resolver knows how it does that. In that case, it happens because any V2 add-on can declare in its package JSON that it's got some non-standard names like that. And so that's what we're relying on here. And you might ask, well, but is Ember Source a V2 add-on? It is extremely close. In fact, it is 100% conformant already. Like, all that's not done is we haven't flipped the switch where it publishes and says I am a V2 add-on, but it functions as one actually if you force Embroider to treat it as one. So for the purposes of this talk, I'm turning on this feature by setting the environment variable in my scripts. The only reason it's not on for everybody is because it would break applications that are not using all this new stuff. Once it's turned to V2, you really cannot any longer use require to get things out of Ember. And you can't do that in your vendor.js and things like that. You really have to use true ES modules. But in our case, that's what we want. So we're opting in to a cutting edge behavior for this demo. Now it runs. We are able to import Ember application. So let's try to use it. So we're just going to go ahead and start to fill in the basics that you would have in an app. We're going to try to make it boot. And let's see what happens when we try to run that. We don't have any build time errors. We do have a runtime error which says resolver class is undefined. This is some exception in Ember. And that makes sense because if you ever look at the app.js file in a standard blueprint, we're assigning a resolver to the Ember app that we make. So let's go ahead and do that. So this is the line that you would normally see, and we're going to do that too. So we need to get that resolver from the Ember resolver package. So we've added that. And now we get a new error, and that's a good thing. We're learning from our errors and we're progressing. This time what we see is global required JS is undefined. And this is the AMD that people have been asking questions about. This is the traditional AMD global loader that Ember always uses. The resolver's looking in there to try to find your code, and we don't have any global loader, and we don't want one. We don't want to have AMD. We're doing this all purely with ES modules. So, but we can solve that problem. The resolver, as of the current version 13, has this new feature called with modules. And when you do that, instead of making it go out and try to find the modules in the AMD loader, you give it all the modules. And so in this case, I've decided to make one route and stick it in an object here and give it the proper naming. And just like in your apps today, we have to say what our module prefix is. This is like the name of our application, so that Ember is going to know to look at from scratch /route/index for the index route. And so this is just a very explicit by hand way of passing modules in directly. The route we created is extremely normal and boring. This is just here so that when we actually get this app to boot, we can tell that it's doing something. And when we look at that in our browser, it's doing something. It's actually running. So we've gotten progress. So now let's look at getting some actual content on the page. We need templates. So I'm going to skip in this example directly to template tag instead of HBS, because we're just going to use all the new stuff. In order to use the new stuff in a route, I'm going to use the Ember route template add-on, which is a convenient way to do that. So I'm adding that add-on. I'm making myself a little hello world template. And you'll notice here, like I'm still wiring all my modules together by hand. So when I'm passing modules in, when I added this new one, I had to actually import it and pass it in. So that's one of the next problems we're going to solve. So we don't have to do that by hand. But in order to make this work, backing up slightly, right? We've got I'm using the template tag format GJS. So what we've got here is not normal JavaScript. It needs to go through 2 different stages, which if you think about how the way you might be used to writing tests with the HPS backtick form or one of those where you put templates in your JavaScript, that is how we go from JavaScript, like templates in JavaScript, to the templates that we run, the wire format. And that is done by this Babel plugin every time a compilation. So we're adding this to our Babel config. This thing is not included in the compat support. The reason for that is that this is a first-class feature that we think app authors should be able to see and control. In particular, it's got extra arguments that you can give it. That's where you would do things like add an AST transformation that you want to apply to all your templates. So with this, now we have the capability to have strings of handlebars compiled into the wire format that runs in the browser. Of course, that applies to things in JavaScript, and our GJS is not JavaScript yet. So we have another thing we need, which is we need the plugin that's actually going to turn GJS into JavaScript. So here we're importing the template tag plugin from the Vite one. We're plugging it into our Vite config. And then that's going to convert that GJS into valid JavaScript, which that can then be handed to Babel, where we're going to compile the templates. And for that reason, we have to tell the Babel Vite plugin, you should run on GJS too, because by default, it's only going to run on JS. So then we get far enough that our template's really rendering. Let's see. So I mentioned that we have we were doing by hand all of our wiring up of modules. And you can imagine that would get old really fast as soon as you've got dozens of templates and services and many other things. And in fact, the problem is worse than just having to put in all your own code, because this resolver does need to know about things that come from add-ons and stuff too. So there's a lot of traditional behaviors there that if you don't want to break them, it needs to know about a lot of things. And so this is something you saw in Chris's talk at the beginning of the conference, which is that Embroider provides this virtual entry point file, and it knows how to find that whole set of stuff for you and produce it as a normal module that to Vite looks like a normal module, as if you'd handwritten it. But we're able to then not worry about all this importing by hand stuff and just say resolver with modules, compat modules. Now every time we add a new file or we install an add-on that needs to add some files, it's going to show up in here automatically. And so now we've got something pretty close to already a full normal Ember development experience. So let's go and let's add full test support too. So tests, we're going to need several dependencies. These are all things that you've got in a standard Ember application out of the box. We've got Ember test helpers, Ember QUnit, QUnit DOM. This is the first time in this demo that I've reached this far where I had to patch one thing. We could go into that in a sec. But if you look at the repo, it shows that we're making a tiny patch against this thing to make it work in our demo. So we need those dependencies. We need a new test index.html file. And so it's got the things that you're kind of used to seeing there. This is where the tests are going to get inserted. We have insert of the Ember testing support. We've got, and we've done a bit of setting up of config environment. I cut out some steps here because I thought I would otherwise go very long. So if you look at the repo, you'll see that we created a file here to hold our config. We're able to update it in this test environment. We're using a Vite feature here, import meta glob, to get all our tests loaded and call our test start. And when we come visit that /test route, we've got it. And we could write a completely normal Ember test and it works. And so that was a really whirlwind tour through setting up a pretty complete Ember development experience. And wow, I actually did it in 20 minutes. I thought for sure I was going to get sidetracked and go a lot longer. But that is the point, right? The point of this talk is to say, even though that was a lot of steps I just hit you with, and I'm sure it's like not something you're going to memorize the first time you saw it, you can look at each of those little steps, and they're small in isolation, and you could learn what they mean. And that was it. That was all the steps. We have a fully working Ember development experience with Vite, and that set of dependencies we looked at is all the dependencies and all the config. So what's not in this demo, right? I was careful here to not hit any V1 add-ons. That's why I was able to go so far without adding a bunch of additional machinery and infrastructure to make things work. So the real blueprint, the one that Chris pointed you at, that's in the Embroider organization on GitHub, it does support V1 add-ons, and it needs quite a bit more setup to do that because it has all of the traditional Ember CLI machinery. You have an Ember CLI build.js. There's more to it because it's much more capable, and it can do many more things in terms of supporting all your add-ons. This demo, though, really paints the way for us to show what does it look like, what does the modern goal state look like, right? Once you're not relying on any older code anymore that's not shipped and ready to work this way, this is how light, small, and fast your development experience gets. And so it is quite close. So V1 add-ons is the big one, and in fact, if you try to take the demo much farther, you'll realize quite soon that Glimmer component is not a V2 add-on yet. I have an open PR and Ember to do that now. And the other major thing that wasn't in the demo that I showed is there's nothing exposed to customize anything in the Embroider macros. I know that's something that definitely library add-on authors in the room are interested in. That's coming soon. It's not in here. That is a capability you have in the full blueprint. That one has it because it still also has all the traditional Ember CLI machinery. It's once you drop that, that's where we get to create a newer, streamlined way to do that, and we haven't shipped that part yet. So the key takeaways here are that we can already show Ember working happily in a fully modern, high-performance build environment. The majority of our core add-ons are V2 because I went pretty far, and you saw a lot of add-ons getting installed. All the testing ones that we installed on that last step, the Ember Resolver, we got quite far hitting nothing but V2 add-ons, and that was pretty good. And this build is hopefully not super mysterious. This is stuff that you can understand. This is stuff that you can contribute to and customize, and that is the point. That is why we think this project is exciting for the community because it's yes, there's a good development experience at the end of it, and you have really nice, fast builds and good feedback from your tools. But even more important in my mind is the really high leverage effect of making our systems much more open and accessible to everybody in the community to help us craft it, help share your feedback on it, feel confident that you can go in and adjust things when you need to, and that you can help contribute to maintaining and supporting these things going into the future. So that's the big takeaway. And that leaves me a little time for questions. And while I do that, I'm going to actually just boot it up for real, I think, because I've been showing you screenshots. And if I was braver and trusted the Wi-Fi, I would have tried to do it all live. But now I can because we made it to the end. Let's see. So the full tour of our project is not very big, right? So I wanted to show you the package JSON here. That's all the dependencies that it took. They fit in one very large font screen. So that's a pretty big difference, right? In terms of the amount of stuff it takes and the amount of things you have to learn and understand to do it. The Babel config is pretty small. The Vite config fits on one screen. And this doesn't, of course, have everything you're going to want. You'll see more things in the big blueprint that supports many more backward compatibility features. If we, for example, I didn't do any handlebars files, but if I wanted to, I would do this. And now Vite understands handlebars files. Right? So we've got a really powerful toolbox that I'm really excited to share with the rest of the community and get more people trying it and using it. And so I think let me call that victory and take questions.
Thank you, Ed, for that. Other questions? Yeah, of course I should have looked. Go ahead.
Should this be part of the V2 add-on blueprint?
Doing it without a pre-build, you mean?
Yeah.
Well, I have wondered if we need like a flag or two blueprints, because I think there's two very different use cases and they both deserve attention. One is that if you really just are like starting something completely new and you want to use only the newest things, or you're somebody who's new to the community and they're kicking the tires and we really want to put our best foot forward, they don't need all the backward compatible stuff, that's just distraction for them, we could give them a very focused blueprint like this. On the other hand, for all of us who have applications they're trying to upgrade, we want to give you the most batteries included upgrade that's going to not make you figure out how to turn on every compatibility feature you need, because you probably are going to need a lot of them if you've got dozens of add-ons and 10 years of history from 1,000 different developers in your repo. So I think they're different use cases, and I think they're both really important. Definitely open to either having literally two blueprints or like a flag, but I think they're both really important. Yeah.
Let's go to the stream.
Yes, we have a question that might be relevant for more of us. I would definitely like the answer. The question is, Babel is used for what purpose? Because I think we don't all know that, and I know you're super smart and live in this world, but what does it do, Ed? What does it do?
I went really fast. Yes, I went really fast, and I appreciate the question. So what Babel does for us is it rewrites JavaScript code into new forms. And so like the most original, say, purpose of Babel was to let you use features in your code that don't necessarily work by the time your code goes out to users on the web. Right, so you could use a feature like ES modules or something like that before your users' computers could actually run that code, because Babel would translate it from one dialect to the other. And for our purposes, we certainly would use it for that. Like when you go to deploy to production, you're going to say what browsers you support, and Babel is going to figure out that if you use a feature that doesn't work in all of those, it's going to go rewrite that feature into code that will work in all of those. That's the basic use case. But in our case here, what initially motivated us was things like the embroider macros. So what embroider macros is that in our code, we can do things. We have several different macros available. So something like is developing app from embroider macros, right? This is like a function you can import, and the special thing about it is that it magically knows if you are developing the app right now. Right? And so you can put code in here that only runs while you're developing. And then when you're not, if you use all the features of embroider macros like this, which you can read about, it's able at build time to do branch elimination, which means if you've got development only code in here and you go to build your production build, all that code will get stripped away. And all the things that it depends on will get stripped away, so that you can have extra stuff that you need only in development that won't go to your users and slow down their experience. So that's an example of what embroider macros is, and it's implemented as Babel, because Babel comes in and sees this code and turns it into something else, or takes it out entirely, depending on what you're asking it to do. So that's so we're using Babel for that. And if the Babel config here is the kind of authoritative source of what we're doing. Of course, we're hiding a few things behind this compat support library on purpose, because there's detail in there that as we iterate on this together and we decide to make an RFC to make this official, we could decide that some things are important enough to pull out of here and make a thing that you actually say, versus just being behind this this big catch-all. But the kind of stuff that's in here is there's a bunch of older patterns before embroider macros that do appear in Ember code, like import env from glimmerenv, or import debug from glimmerenv is a thing that Ember code says in some places. And it's supposed to have a meaning kind of like is developing app. That stuff is all in there. And, I'm sure there's other things that I'm not thinking of right now. And then the template compiler, this one is what takes, let's see if we can let's boot this thing up and see what we can see. I think it would be instructive. So that was our booting up, and open up my browser. Where are you, Chrome? Here we go. The real blueprint is on port 4200 for traditional purposes. This one is just using the Vite default. If we look at our code, something like one of our templates. So the template that we authored here looked like this. So there's a GJS file. It's got a template tag, right? I mentioned there's two stages of template compilation. The first is that we have to turn our GJS into JavaScript because this isn't JavaScript, right? Template tags are not a normal thing that works in normal JavaScript. And we can actually see where that happened because what Vite is showing us here, so this is the actual file that got loaded into the browser. You can see its name is actually just app templates index.js. This is the source mapped version. So this is what, once Vite saw JavaScript, this is what it saw. And so you can actually see this is already past the GJS transformation. This is the JavaScript equivalent of that GJS. There's no more template tags. There's instead this template function imported from Ember. That means the same thing. And this whole bit is there. You can go read about this in RFC 931. This is there because it does make it possible to explain why is it that this thing can actually access values out of scope, right? So the template is using this example, even though if this was truly just a string, it wouldn't have access to it. It has access to it because of this eval pattern. But all of this is an intermediate because when it finally gets to the browser, so if I click down here in the DevTools, I leave the source map and I see what's the real running code. And this is what Vite compiled it to by the time my browser is actually going to run it. And so now my template is very different. I have this thing, which we would call wire format. This is the completely optimized down version of my template that's just ready to run and boot as fast as it can. In development by convention, it still has as a comment the contents of my original template here. You can see that I was calling a component named example. But it's quite different. And so this stage, to go from here to here, that's what the Babel plugin, this Babel plugin Ember template compilation is doing. So it's another example of using Babel to read your source code and decide that it's going to replace it with different source code that, because that's what you really want to give to users. You want to look at nice source code for you to look at and work on, and you want to serve to users the code that's going to run best for them, and they're not exactly the same, and Babel's managing that difference. Yeah, so great question that led me into some things that I would have wanted to put in the slides if I thought I was going to go a lot longer.
We got one more question.
Gonna put you on the spot just slightly. Yeah. If you go back to the package JSON that you have here.
Oh, yeah.
And how lovely and pretty and short the list of dependencies is.
Yeah.
The thing we're glossing over is Ember source. And how many sub packages are really inside of that we're importing from. And PNPM and Vite don't really want us to reach in to something that's not actually in our dependencies as a specified thing. So we have, what are we going to do around these virtual packages?
I mean, it all works really good. I mean, it's one little resolve hook. So, because of the mapping, well, actually, I can bring it up for you. So this version of Ember Source is like the latest canary, which I was in fact shipping features in this week to make this more smooth. It has in it metadata. So any V2 add-on, here we go. So any V2 add-on can use this Ember add-on section to use a feature called renamed modules. And it's a map of, when users ask for this, pretend they really asked for that, right? And this is all the things in Ember Source. There's a lot of them, you're right. But you can see that this is a fairly light and transparent feature. Implementing it as a Vite plugin is pretty easy. What's more, if we see really good ecosystem adoption of a spec like import maps, this could just be that, so we don't even have our own kind of metadata. We can just use a standard feature. So it turns out that it's not that big a deal. It does mean, yes, we have, what it costs us is this line in our Vite config. So and I don't think there's a lot of caveats to having that. And there's a lot of things. And even if we decided to like solve that exact problem, there's a couple ways we could. We could publish all the separate packages and make people install them. We could also decide to rename things slightly. Like if you drop the @ sign from all those imports and it becomes Ember/component, now you can just ship a package named Ember that has all those things, and it would be totally conventional. So those all have their pros and cons. But even if we did that, we would probably still need this because there's just a bunch of other behaviors that code in the ecosystem is relying on. For example, app tree merging, right? We've seen in the in the previous talk about the V2 add-on monorepos, we saw code about the app.js entries that let you re-export code into applications, right? That's a behavior that add-ons have had a long time. They still need for certain things. And it's a very complex pattern that is annoying, and we should definitely be moving toward the exits. And we have in a lot of ways. All your components, your helpers, your modifiers don't go through that system anymore once you're using template tag. They're all just imported where they're needed. But if an add-on has a service, the process by which that ends up found by the application is still complex enough that you're going to need this resolver there. So I expect it to be there for quite some time. And so I don't see it as a pressing barrier to do the thing you're saying. I will also point out that it all interacts great with the Vite dependency optimizer. When we look at what Vite did with our code here, these are things that came out of Ember source, and it optimized them into the Vite depths, right? And so it found that these are different entry points into there. This is internal stuff for Vite, but the way that how it tries to make your development experience fast is your code, it's serving every individual module out to the browser, and that's what gives it great caching, because when you change one module, it just has to serve one module. But for your dependencies, if you have, you've got several big dependencies, and Ember is certainly one of those, the dependency itself might have 1,000 modules in it, and it does make things boot up much faster if before you even start developing, Vite can take those 1,000 files and build them all into a small number of files. So that's what the dependency pre-optimizer is. And you can see all the things that it made because it literally puts them here into this folder, node modules.vite deps. And we have those. We can see what did Vite actually find in this example, right? Let's see. There's a bunch of shared chunks. There's Ember Resolver became one, Ember QUnit became one. Ember Source had several different entry points. So you can actually kind of see the packages, the fake packages, really did actually get their own entry points here and got pre-optimized by the dependency optimizer. So we're in a pretty good place. I don't think we're really sacrificing anything.
One more hand going up. Yeah? Okay. I'll do that one last question. Good. These questions are great.
Hey, thanks, Ed. One thing I've been missing for a long time while developing is the ability to place breakpoints inside VS Code and have them correctly bound to the source, because so many transforms were happening because of CLI and everything. Mm-hmm. So my question is, do you believe that now that we are about to use Vite and that there's going to be less transforms in dev mode, do you think this is something that would work?
That's probably much closer. I haven't tried it. So I think that you're right that it comes down to having a chain of source maps through all the layers. As we can see from the example we just looked at here, this source map doesn't go quite back to the code we authored, right? This doesn't show the GJS, which has pros and cons. If this was GJS, I don't know the Chrome DevTools would know how to syntax highlight it correctly, for example. But at the same time, if it was GJS, I think a breakpoint, then if we actually, run Chrome plugged into the VS Code DevTools, you'd have a better chance of making that work. So I'm guessing right now we're not plugging the source maps through from the template tag layer to this layer, but we could. We do produce high quality source maps at that stage, so we should look into how to plug them in. Yeah.
Thanks. Well, and that's it.
Thank you so much.
Yeah, thank you.